We now move to relational language and database design. We'll look at relational calculus, tuple relational calculus, domain related calculus, query by example, design process, entity relationship, constraint, ER diagram, setting entity sets versus attributes, setting entities versus relationship, so attitude relationship, use of entity sets versus attributes and relationship, binary versus an array relationship, aggregation versus ternary relationship. So this entity relation diagram forms a very important thing here. It's how the data is related. There could be weak entity sets as well. An extended ER feature includes class hierarchy and aggregation. So there are some attributes to these entity sets. They are bound by some relation. They are binary versus an array relation, aggregate versus tertiary relationship. We could also have weak entity set. So the end goal of this chapter is to start with relational calculus, tuple relational calculus, domain related calculus, query by example, and then slowly move into the design process, which is the entity relationship modeling, where you want to really create a structure where you can understand how data is coming into your system and how to store that, how they are related. So relational table can be considered as set. The row of the tables can be considered as elements of the set. Operation can be performed on sets, can be done on relational tables. Relational data operation are used to retrieve required data from relational table. Data is retrieved using queries, and queries are formulated using data operators. To be able to use database to store data, it should be designed in an efficient manner. The first step in designing is database is data modeling. Data modeling enables database designer to create a model that represents the way in which information is likely to be organized in database. The two major methodologies are entity relationship diagram and object model. The main focus here is the entity relationship diagram. So this is about sets. So relational calculus is an alternative relation in contrast to algebra, which is procedural. Relational is non-procedural or declarative. It allows to describe set of answers without being explicit on how they should be computed. Relational calculus have a big influence on design of commercial query language such as SQL, and especially query by example. The variant of the calculus we present data is called tuple relational calculus, TRC. Tuple variable is a variable that can tuples on a particular relationship as values that when assigned to give tuple variable. A tuple relational query has this form: T, and we know P, and where T is the variable and PT denotes the formula that describes the tuple. So find all sailors for rating above 7. So this would how we go. Syntax of TRC queries. We know that the definition, the notation, RELB relationship, SLED operation denote greater than, smaller than, equal to, and we can skip this for now. So semantics of TR queries, again we can skip this. Domain related, we can skip this. Let's look at query by example. So query by example is another language for querying like SQL for creating, modifying relational. It's different from SQL for most other in having graphical user interface. A user write queries by creating example tables. QBE uses domain variables in DRC to create example. The domain variable is determined by the column which it appears. The unit introduce QE through example of queries. So overview of the design process. The primary focus here is to design the database, and it could be divided into 6 process. Requirement analysis. The first step to understand what is data stored, find out the user, what the user want, study the current operation environment. So that is requirement. Then you have conceptual database design. The information gathered is used to develop a high level conceptual database, how user developer think of the data. So a discussion. Then logical database design into a database schema in the data model, a collection of high level data description model. We'll consider only relational DBMS, entity relationship diagram. So that is logical, and this is conceptual. Then we have schema refinement, is to refine less collection of data in a relational scheme. Physical database design, database involves building, indexing tables, or listing some table or manual design of parts of schema. Then we have application and security design. So after the logical, conceptual, and the requirement, the 3 others are like schema refinement, physical database design, the application, and security design. So entity relationship models allow us to describe data involved in a real world enterprise object and the relation to develop an initial database design. ER model is important only in database. It provides useful concept that allows the change the detailed information and informal description of what user want to precise Even though ER model describes the physical database model, it is basically useful in design and communication of logical database. The overall logical structure of a database can be expressed graphically by ER diagram. So we have entity 1, entity 2, relationship and attributes. These are the three things. So rectangle which represent entity sets, diamond which represent relation, ellipse which represent the attributes, and lines which is the relation. So here you can see this arrow. So relation and entity would be joined by arrow, whereas you don't see an arrow in the attribution. So you have rectangle, diagram, ellipse and line. Then thing or object that distinguish objects is the relation remains associated connection different entities. So this is the key. Let me see where they have described about this, ENO and DID. Okay, I think it's here. So entity class employee department works out details which are represented by attributes, ellipse, employee detail and employee name, ENO employee salary and DNO. So then we have got the constraints in the diagram. Okay, so here the employees are like linked with various numbers. This is the employee and the department entities: manager, department, employees, salary, E-name, ENO, DID, D-name, budget, managers and cents. Participation constraints, ER diagram. There are many steps. Now let's look at the steps. Identify the strong and weak entity sets: employee strong, department strong, project strong, dependents weak. So dependents is weak, not told yet. Identify the relevant attributes. The next step is to get all attributes necessary. So employees, it would be like SSN name, address, date of birth, date of age, projects. Identify the relationship sets: employee and department, department and project. So identify those relations. Identify coordinate ratio and participant constraints. So whether it's 1 to 1, 1 to n, m to n. So these are called the coordinate ratio and participation constraint. Identify is has a relationship set. So has works for, manages works on. So use of entry set attributes, use identity sets of relational sets, binary versus entry relationship, and aggregation versus ternary relationship. So these are some issues. Before that, let me re-talk about the steps that you have to do to create the entity relationship diagram. So identify the strong and the weak entity sets, identify the relevant attributes, identify the relationship sets, like these are arrows of what we're doing. So works for, manages, controls and work on. And you will see that this goes into this diamond. So department and project, works for, manages and so on. So ER design issues are like use entry sets, attribute, use entity relationship set, binary versus entry relationship, aggregation versus tertiary relationship, use of entry versus attribute. So binary versus n array, aggregation, tertiary relationship. Weak entity sets. Now entity set that does not have primary key with them is termed as weak entity set. An example is set with payment, which has got 3 attributes, ER diagram. So the weak entity payment is independent and doubly box underlined because each payment is distinct payment from different share the same payment number. In the above feature, weak entity set payment is dependent on strong entity set loan. An entity that has primary key termed as strong entry by relationship loan. The below figure illustrates double line to indicate total participation. The participation of weak entity set in the relation loan payment. It means that every payment must be related via loan payment to some account. The arrow from the loan indicates that payment is a single loan. Discrimination of weak is underlined with dash rather than solid line. The discrimination of weak set payment, which is formed by the primary location of strong on which weak entity set is dependent. That is the case when weak entity send payments. So the extended features then are class hierarchy, where so into sub classes known as class hierarchy, we want to classify employee set into subcategories only. And the class hierarchy is like specialization and generalization. Class hierarchy based on constraints, covering constraints. And then we have aggregation, allows to integrate the relationship set participates in other sets. This relationship set in association between entity sets and use of aggregation. So this is the summary. The basic operation is select, project, Cartesian product, union, difference operator, intersection, join, division, rename. ER model allow us to describe data involved in the real world in terms of entity relationship. Relational algebra is an algebraic notion when queries are expressed by employing specialized operation. Relational calculus is a logical notion where queries are expressed following some logical restriction that tuples in the answer must satisfy. And unary operation which operates on only one relation. So that would do it for this session. Thank you.